Good morning, my friends. Finally, we will touch base for the last part of about this question. So, the new scenario is like this. Our induction motor now is about to work as an induction machine and work as the function of a generator. Okay, it's a delta connected generator. Theoretically, our inductance machine is composed by a stator outside and a rotor inside. So if we apply a power source, AC power source, to the stator to make the rotor rotate inside, it works as a motor. However, if we use some external force to make the internal rotor rotate first and to generate EMF in the coil of the outside stator. That function is called a generator. So basically, we can use the inductance machine to play both of the role, generator and motor. Decide which one is rotating faster. Yeah. Okay. Presently, we have an induction generator with a delta structure, and it will supply the power with the line voltage of 435 to a also delta connected three-phase load. So the structure is delta to delta, okay? Because basically, between the relationship with generator and the load, there are four different structure, which is Y to Y, Y to delta, delta to Y, and delta to delta. All right. And another thing, don't forget it. This is a load with a Y structure. This is a load with a delta structure. This is Y. This is Y R delta. So basically, R delta equals 3 times of RY. Okay, remember it. All right. So the first question is asking us to draw the equivalent circuit. So I don't think there is much difficulty for us to draw the circuit diagram, which is like this. This is source. Sorry, it's a delta to delta, right? So this delta to delta is like this. Be aware that if we have a Y structure, it should be three-phase four-line. Why they are four-line? The fourth line is called neutral one. You know the neutral one. But to our delta structure, we don't need the fourth line. We just need three line. This is VA, VB, and VC. This is R. Sorry, this is Z. Z equals 6 plus 0.9 J ohm. Okay, that's the structure for the first question. To the second question, we need to calculate the phase current of the load. All right, we still based on the Ohm's law. The phase current equals phase voltage divided by Z. All right, we already get the value of Z, which is 6.07. Oh, sorry, which is 6 plus 0.9 J ohm equals 6.07, and the angle phase angle is 8.53 degree. And we also have the phase voltage equals 4 35 volts, which is given by the question. Be careful, in the question it said this number is for the value of line voltage, but for the structure of delta, the line voltage equals the phase voltage. That's the same. The difference is about the line current is square root phase current. But that's another story. All right, we get the value of Vp, we get the value of Z, so we can easily calculate the phase current, which is 435 divided by 6.07, and the angle is 8.53, which is 71.66 minus 8.53. The unit is ampere. All right, finally, we reach the bottom of this question. We are going to calculate the total real power, and the total received power of the load. Real power, as I mentioned before, S equals P plus JQ. This is apparent power. This is a real power or active power. This is apparent. And this is a reactive power. Don't forget their names. All right. If we want to get the value of active power or real power, we can use basically two equations. First one is P equals S times cosine theta, which is VI cosine theta. And another equation is I square times R. I square times R. In this question, we will use this one. Okay. Currently, we get the value of IP, and we get the value of R, so we can directly calculate the total entire real power, which is 3 times, because it's 3 phase, so we need the times the factor of 3, and I phase current square times the resistance, which is 3 times 71.6 square. So this is the phase current we just calculated. We just need its value, we don't need its angle. And the real part of the impedance, which is the resistance of the load, is 6. So the final answer is 92,442.9 watts. Okay, similarly, the Q equals 3 times IP squared times X. Okay, yeah. In this system, we know the Z equals 6 plus 0.9 J. This is a positive number because we know X includes two types. One is from the inductance, which is XL equals omega L. The other is from capacitance, which XC equals minus omega C receptance. All right. So most of the case for our wire or cable or transmission line, there is only inductance existing there. So most of the case we use the inductance here. Okay. All right. Now we can back to our question to calculate this number as 0.9, which is 1386.4 VAR. Be aware of the unit for the real power and the reactive power. All right, finally we get all the questions solved for this problem. Hope you can enjoy the process and my explanation. Thank you very much. Bye bye.